Good day, this is Professor Elliott again, and in this presentation we will look at sine waves, square waves, and triangle waves, but primarily we're going to focus in on the sine wave and some of its basic parameters and characteristics. Okay, so I'll just point out a few things, then you can just take some time to read this slide, and then I'll just kind of wait for you. So direct current, which is DC, which you're already familiar with, that's what we've been using all semester. The current or the voltage does not vary with time. So it's either all positive or all negative, but it doesn't switch between the two. So if you have a 12-volt car battery, it's 12 volts, it's 12 volts, it's 12 volts, it's 12 volts. It doesn't change with time. Okay, so it's constant. Alternating current, generally by default, unless specified otherwise, we mean AC sine wave, and I've given you a little picture here. That's an AC sine wave. Square waves can be AC, square waves, AC. Notice how it goes positive and negative. Or it can be DC, but it's not like a battery, it's not flat line. This is actually called pulsating DC, and it could be all positive or negative. In this case, it's simply positive. Okay? So I'll just you just pause the video and then just read over the slide, and then when you're ready, then just continue on. Okay, so triangle waves, like square waves, they can be either all positive, all negative, or they can be AC. So in this case, I've drawn an AC triangle wave. Notice how it goes equally symmetrically positive and negative, but it could be all positive or negative, in which case it would be pulsating DC, technically, just like we saw on the last slide with the square wave. The other thing is the period or cycle, which we're going to look at a little bit later. It's the amount of time it requires before the waveform repeats. Okay, and that's expressed in other seconds, milliseconds, microseconds, and so forth. And that concept is exactly the same regardless of the waveform type. Okay. Average voltage for a sine wave over the entire cycle is 0. Okay, that's because the positive half and the negative half, they're all symmetrical, and if you average them out, it's actually 0. Instantaneous voltage, so there's a formula down here which you can use then to solve for the instantaneous voltage at any point in the sine wave, and we'll talk more about the degrees a little bit later. So this is the basic sine wave. I've shown one complete cycle, and I've identified the period, the positive peak, the positive RMS, the negative RMS, and the negative peak. Of course, the positive peak and the negative peak will be the same number, just opposite polarity. Likewise for the RMS, and the waveform, it repeats every 360 electrical degrees. If that point would be 0, then that point again repeats over here. So in actual fact, the sine wave, the next cycle is going to go like this. So this would be 360 degrees, and that's one period or cycle. Okay. Formula to convert from peak voltage to RMS, right? Or RMS to peak. You can go back and forth between the two. This is the rule of thumb approximation, which is what I use and most people will use. This is technically a little more accurate. You can use either one, will give you exactly the same answer. So anyway, make sure you know those formulas. They're pretty fundamental and basic. Okay, so here's I've just marked up some of the key voltages for a standard household line voltage, like out of your duplex receptacle. So it's at a frequency of 60 hertz. It's 120 volts. If you don't add anything, say anything further, assume the 120 volts to be RMS. So I've marked on the RMS voltages for you here. Okay, the peak voltages are there. It's actually 169 point something. I just rounded it off. So again, to convert from the RMS to the peak, we'll go back to the previous slide. So we can simply say that V peak equals the V RMS divided by the 0.707, or multiplied by the root of 2, whichever you prefer. So that's 120 volts divided by 0.707 equals approximately, if you work it out, 170 volts. Okay, and that's the values that I've shown here. All right. Okay, so this talks a little bit about the RMS. RMS stands for root mean square. It's also known as an equivalent heating effect. Okay, so again, to go from the peak to the RMS, you multiply by 0.707. Keep in mind that your DMM, unless the meter says otherwise on the panel or in the instructions, usually they'll say run the panel. If it says like true peak or something like that, then it's only going to read RMS. And oh, by the way, RMS is only meaningful as applies to sine waves. Okay, when you're dealing with square waves or triangle waves, okay, RMS doesn't mean anything. Only with sine waves. Okay, so frequency and period. So I already mentioned that the cycle or the period is when the waveform repeats. Okay, so that would be from like that zero crossing, if you follow it through, it repeats there. So that distance from there to there, that is called the period. And this slide just illustrates the difference between a low frequency or a high frequency. Basically, in a high frequency, there's more cycles in a given time period. Technically, the definition of a hertz is 1 hertz is 1 cycle per second, and as the frequency goes up, we can fit more cycles per second more cycles into that 1 second window, if you like. Okay, so there's some practice conversions. Make sure you can manage those. All right, converting the first case, I give you the frequency, convert the time. Time is the same as period. Over here, I give you the frequency, right? I give you the time, calculate the frequency. Okay, so we're dealing with hertz. Hertz corresponds always with seconds. Kilohertz with milliseconds, megahertz with microseconds. And there's the 2 formulas you need. Okay, so these are practice questions. Make sure you do all these conversions. Okay, just pause the presentation, fill out the chart, and then when you're done that, go over here, check your work to make sure, see if you're on the right track or not. Okay, so once again, reached the end of another video, and I hope you learned a little bit. Okay, thanks guys, bye-bye.